Hey Algebra 2 guys, this is a little video on section 1.5, solving quadratics by finding square roots. It should be a little bit of review for you. I'm pretty sure you got to this in Algebra 1, so I hear. But it's really important to have a good understanding of it, because when we do the next section, section 1.6 on complex numbers, a lot of these same type properties and processes will apply to those and work. So first off, in order to simplify these radicals that we're going to be messing around with while solving our quadratics, you have to know these two properties. They're very important. The product property and the quotient property. And basically what it's saying is, if you are to have two things multiplied underneath a radical, you can pull them out and separate them and have radical a times b is the same as radical a times radical b. Square root of a over b here, quotient property, same thing. You can pull them out in two separate radicals, the quotient of two radicals. So we are going to be using these properties in order to simplify our square roots or radicals. Here's some examples here. Square root of 28, we can break that down into 4 times 7. Your objective is to think of a square root that goes into the number under the radical, and this is why. 4 is a perfect square, so when you break them out, you get this. This is 2, right? That's why you're looking for the perfect squares, times radical 7. Another one here, a perfect square that goes into 150. Well, I'm pretty sure that 25 goes into 150, and that's a perfect square. And that would be times 6. We know that the square root of 26 is because of the product property. This is true, right? So 5 times the square root of 6 is our answer. This is radical 150 simplified. Right here, to do this, we have to rationalize the denominator, and what that means is get the radical out of the denominator to put it in the proper format to work with. So to get rid of that radical, what you do is you multiply the numerator and the denominator by the radical. First of all, why can you do that? Why is it okay? Radical 12 over radical 12 happens to be what number? Hopefully you're saying 1. If you multiply 1 times a number, do you change its value? Hopefully you're saying no. So we're just multiplying by 1, and that's not changing the value. So when we do that, the numerator is going to look like this. The denominator is going to look like this. Now when we square our radical, it actually just kind of strips the radical, because square root of 12 times square root of 12 is 12. So that brings us to here. Now technically we're not done yet, because we can actually simplify that 12. So I'm going to go one more step. That is 4 times 3. I'm going to come over here. So we have 7 times square root of 4 times square root of 3 over 12. One more step. This right here is 2, so I'm going to skip a step. 2 times 7 is 14 times square root of 3 over 12. And we're still not done. We can reduce this. Okay? 2 goes into 14 7 times. 2 goes into 12 6 times, and we've got times radical 3. Ooh, I ran out of space there, but you get the idea, I hope.